Have you ever wondered why we still use gunpowder to propel bullets instead of high explosives like TNT? I mean, high explosives are more powerful, right? Shouldn't we just be using the most powerful explosives we can find to get crazy high velocities? Well, today we're going to explain why you don't do that. If you're like me a week ago, this might sound like a convincing argument to you, but I'll explain why it's not. It all has to do with material science and the differing properties of low explosives like gunpowder and high explosives like TNT or C4, and what these differing properties mean when it comes time to fire a bullet. First, let's get into physics of what actually happens when you fire a round of ammunition. It starts with a firing pin striking a primer, or in the case of rimfire ammunition, a rim. This sets off a small amount of shock-sensitive explosive. Originally, this would have been mercury fulminate, which you might know from Breaking Bad. But now it's a mix of other chemicals, some of them corrosive, some not. This smaller explosion sets off the gunpowder charge. This burns, creating high pressure gas. It's this high pressure gas that propels the bullet out the barrel. Let's start with Newton's second law. Force equals an object's mass times its acceleration. If you want to get a high velocity, you want a high acceleration. And one way of doing that is by increasing the force. Now, the definition of pressure is a force over an area. We can rearrange that with a little bit of algebra to get force on its own and find that the force equals the pressure on an object times the area that the pressure is being applied to. In the case of a bullet, this is its base. Now, the base of the bullet is circular, so its area is equal to pi times its radius squared. In guns, though, we don't talk about the radius of a bullet. We talk about its diameter. So that would actually equal pi times the diameter squared over 4. So by increasing the pressure on the base of the bullet, we are increasing its force. Increasing its force increases its acceleration, and that increases its velocity. Now, if I was being very specific, I would factor in the friction between the bullet and the barrel, but I'm kind of lazy right now. So let's address a common misconception that many people, including younger me, have about what separates low explosives from high explosives. It's not as simple as just high explosives powerful, low explosives weak. Let's get a little bit into the chemistry right now. One example of a low explosive is smokeless gunpowder, whereas a high explosive could be something like TNT. Both of these are actually made of the same elements: carbon, hydrogen, oxygen, and nitrogen, though their combination differs. Another similarity between these two examples is that they are both self-oxidizing. Many explosives are non-self-oxidizing. This means they have a fuel and an oxidizer that need to be mixed in order to go off. One common example of this is gasoline being the fuel and the oxygen in the atmosphere being the oxidizer. In self-oxidizing fuels, the fuel and the oxidizer are stored together in one molecule. Now, despite these similarities, when it comes time to go off, TNT and gunpowder behave very differently. Now let's get into what definitionally differentiates high explosives from low explosives. High explosives, like TNT, when they explode, they detonate, whereas low explosives like smokeless powder deflagrate. When high explosives like TNT detonate, they create a supersonic pressure wave that sets off adjacent molecules of TNT. It's important to note that this is supersonic in the material, not supersonic in atmospheric air. TNT, for instance, can detonate at 22,000 feet per second. For practical purposes, what this means is that it releases all of its energy and pressure almost instantaneously. Smokeless powder, on the other hand, deflagrates or burns. When in deflagration, the chemical reaction is not spread by a supersonic shockwave, but rather by heat. One example of deflagration is gasoline in your car's engine. When it burns, it does not instantaneously explode, but rather burns slowly, creating a gradual push. While still instantaneous to the human senses, gunpowder firing or deflagrating takes substantially longer than TNT detonating. One engineering obstacle towards using high explosives instead of low explosives to propel a bullet is the material science needed to handle higher pressure. You can see this in the SIG 277 Fury cartridge, just adopted by the US military. It uses gunpowder to create pressures of 80,000 psi. That's almost 20,000 psi higher than 5.56 NATO. And this higher pressure necessitates many engineering challenges. First, it has to use a two-piece case, with the base of the case being made out of stainless steel. Because if we were to use simple brass, it would rupture, releasing high-pressure gases, which is not a good thing. There are also engineering considerations that have to be taken into the gun itself. The barrel, due to these high pressures, is extremely thick, especially around the chamber, and the locking lugs need to be longer than in an equivalent lower pressure battle rifle like the AR-10. Using high explosives would take this problem to the nth degree. But wait, can't we just use a smaller amount of high explosives to generate a safer pressure? Well, this is where the difference between detonation and deflagration come in. With detonation, all the pressure is created instantaneously. But with deflagration, it continues to burn while the bullet's in the barrel, giving it a more consistent push. Think of it as a bobsled race. On one side, you have four guys pushing as hard as they can to try and get gradual speed added to the bobsled. On the other hand, you have the Hulk just kicking a bobsled. If you want to go as fast as possible without destroying your gun, you don't want the high explosives. You want gunpowder. Another advantage of gunpowder is that you can change the rate at which it burns by changing its size and shape. When gunpowder burns, it burns on the surface first. So if you make high surface area flakes like those used in pistols, you can make it burn faster, which is ideal for pistols because you have a shorter barrel with which to accelerate the round. Rifles, however, often use ball-shaped gunpowder. Another advantage of gunpowder over high explosives, or at least the safe ones, is that gunpowder can be set off with just the heat from hitting the primer, whereas you usually need a supersonic pressure wave to set off high explosives like TNT or C4. This is great for safety reasons, but it makes it impractical, if not impossible, to be used in a conventional cartridge case. Today we learned why we still use gunpowder instead of more powerful high explosives to propel bullets. If you liked today's video, make sure to like and subscribe. And if there's anything you'd like for us to cover in a future video, let us know in the comments. See you in the next video.